Hello, welcome to everyone. Good morning, good afternoon. My name is Santiago Rodríguez, and in this talk we will be presenting phishing. According to the FBI, during the last year, there has been an increase on 69% on phishing reports by users or by companies. This means a $4.1 billion losses, and we don't have these same numbers on Argentina or the same statistics to compare, but some reports by Telam show us some numbers. I will be sharing with you the links at the last of this presentation. So phishing is a really common attack. Just by checking at your spam folder on the email, you can see every day tons of emails trying to trick the user. So it's this topic is quite well managed by our email providers, but this topic is not so well covered on our mobile devices. So this is the main focus of this presentation: how phishing is getting more complex and how phishing is trending to mobile devices. I'm a security researcher working on a company named Zimperium. I have a background on computer science and embedded systems. And I have been working in Zimperium for phishing detection for the last 2 years. We will give a brief review on the phishing global stats. That's general phishing. After that, we will be covering some specific trends on mobile market and mobile phishing, some of the common techniques used for phishing, and what we can do for phishing detection. So starting with some global stats. Information collected by Zimperium during this year show us that more than 50% of the phishing sites are hosting in the United States. This doesn't mean that these 50% of the phishing sites are targeting US companies, but there's a correlation with these numbers. We can also see what are the most phished brands and what are the most phished categories. If we classify these brands into categories, we see that more than 50% of the phishing are targeting financial companies or social network companies. We also can say that we have how long a phishing site is living. We have a term that's named 0 day. This means how long a phishing site it's working before it gets discovered or it gets added to common or public blog lists. According to Zimperium data, we have an average of 5 hours and up to 6 days for a phishing site to be active before it gets discovered. When we say end day, we mean how long a phishing site is active after it gets discovered. And we see that we have an average of 2 days and as long as 1 year of a phishing site being active, and it continues spreading and tricking users after 2 days or 1 year. Now we will continue to the mobile market. We can see a trend on the mobile devices usage. For the last 10 years, there has been a big growth on the mobile market and the mobile devices usage. At the moment, as we can see here, we have more than 50% of the users are accessing a website on mobile devices. And as total numbers, we can see a growth of year after year in mobile usage. So this means that the users are constantly affected by phishing and by attacks. And if the users are using each day by day more their mobile devices, they are always getting at risk. With this increase on mobile usage, we can also see an increase or a trend on the mobile technology trending to mobile. Here we have also for web developers the well-known responsive or adaptive designs. Responsive means a website that adjusts all its content to the final screen. So the same HTML adapt the rendered website to the screen that it's rendering or showing it to the user. Adaptive websites mean sites that load a completely different HTML according to the device that it's requesting the website. We can see up to last couple of months how are the mobile screen resolution shared by the users. We see that most of the users are seeing websites in small screens or small resolution. This means that the user have less information to decide if the content that they are seeing is legit or is not. So with this information or with this background, we will start talking about phishing. Phishing is growing in complexity. So we can see that in the last 2 years, we have an increase on sites using HTTPS from around 30% to more than 50%. This means that users trying to trick another users or attackers are requesting or generating certificates. HTTPS means that the communication between the client and the server is secured. It does not mean that the final website that we are visiting is a legit one. So this is a common thing that tricks the user. When a user accesses a HTTPS site on a mobile device, we can see this icon from a log. It generally tricks the user, and the user thinks that he is on a secure website. So we here have two phishing sites, one trying to phish office and a bank. Both are not the URL from those companies, and they are secured connection, so all of these things can trick the user. Zimperium research also give us some statistics on how the phishing are targeting mobile. Here we have another graph showing phishing sites collected during the last 2 years that have specific content to mobile device. So are phishing sites that are targeting mobile device or are rendering in a good way on a cell phone or on a tablet. We see an increase from less than 50% to more than 75% in the last 2 years. We also found phishing sites that are rendering different content according to the device that is asking the server. For example, we see here a phishing site that if it's accessed from a mobile device, it will be phishing Netflix. And if it's accessed from a desktop site, it will be a legit site. In general, attackers do this to avoid being detected by desktop apps or by desktop solutions. In general, in desktop, we have much more information or much more compute power to process and to decide. So a phishing site that is rendering a legit site, or like this one, an error on desktop, tries to avoid the detection on desktop's site. Another common techniques or common usage of phishing targeting mobile is URL padding. We see lots of URLs for phishing with this kind of form. In here we have a phishing site that is trying to phish Facebook, and with this kind of URLs, probably in some all browsers, final user can see something like that and is hiding the real domain. We see that at the moment around 1% of phishing sites are using these techniques, and this is probably because modern web browsers on mobile are showing in a second line the real domain. Other mobile phishing techniques are smishing. Smishing are phishing over SMS or WhatsApp. Smishing usually are using also shortening services or tiny URLs. Tiny URLs are URLs used or services used to shorten a long URL. So a legit domain in this case, like bit.ly, is used, and if we only analyze that, we can see that okay, bit.ly it's a legit site, but this is redirecting to another website. And also in some shortening URLs providers, we can choose what will be our chain, so a user can ask for a URL like this one, bit.ly PayPal sign in, and this can try to trick some users. Another techniques used on mobile are screen overlay. This is coming from the malware world because it needs for a malware app to be installed in the device. It's an app that it's rendered over another app and trying to mimic a form. In that way, steal some user credentials. Here we can see another example, an app from a bank with a form over it, and if we see what are these apps, we have the real app bank and another app that it's rendering the form over it. We have also found some phishing techniques using HTML5 full screen API. We can see a site that when it's accessed, it is asking to render in full screen. The full screen rendered is an image trying to mimic the way that the user operating system is looking. So we here can see a site that when it's rendered in full screen, it is showing an image of a quite old macOS operating system view, and it is rendering a fake URL bar showing Bank of America. But we see here that this is not the actual domain that is asking for this. So with all these new or common techniques, or attackers are always trying to innovate in new ways of attack, we have to think in new ways of phishing detection. So most of web browsers are using blacklists. So we can see the mobile market share here. We see that most of the most used web browsers are Chrome and Safari. Those web browsers are using GSF, the blacklist used by Google to stop users from accessing a website if it has been detected. Edge and Internet Explorer also use denied lists. So if we remember the 0 days statistics, we see that a phishing site in general is active for 5 hours before it gets detected. So it gives us a time of 5 hours of an attacker to send and populate its attack before it's on the block lists. So we have in general a lot of time for users unprotected. So we need some 0 day methods or 0 day defense to try to detect those phishing sites at the moment that they are accessed or at the moment they are created. So we will be presenting a machine learning pipeline or methods that are using machine learning or analysis over the URL, the domain, different contents on the website that we are trying to analyze to decide if it's phishing or not. So if we start with at the left, we see the less information we have or the less we need to know or to request to decide if it's phishing or not. And at the right, we have data that needs more latency, or we need to download or to get more information to decide. If we start only with the domain, we start analyzing the domain, checking with the blog list as the browser do, but we can always find some words hidden on the domain. For example, in these cases, we have 2 domains that are trying to mimic PayPal or Facebook. So we have tools to analyze the strings and to get how similar these domains or these chains or characters in the domains are to common phished brands. Also, we can find high entropy chains on the domain, like this one. This is a URL from a phishing site, a domain from a phishing site. that have a really long number or a really long chain. That is very common in phishing sites. It's very common to have phishing sites that are using some well-known or legit domains. For example, in this image we see a Google form that is hosted on Google. We see the domain here, docs.google.com, and this form is trying to phish AT&T. So if we get or we analyze this domain, we will get a legit domain because the domain is Google, but it is actually a phishing campaign trying to steal user credentials. So if we rely only on the domain, we will lose lots of real phishing sites. We can continue seeing the full URL. In the full URL, we have sometimes the same techniques we can use to detect common words or trying to fuzzy match some of the internals chains on common names, also trying to get the entropy of the URL. If we continue in the amount of information we get from a site, we can check for the certificate the attacker is using. We have some good reputation certificates used for phishing sites. We can see here a site that is trying to phish the user or to get some credentials. This is a site hosted on using HTTPS. Is using a valid certificate, and we can see at the validity times or the subject alternative names to try to get if this certificate is being used in another websites or for another purposes. We can also analyze the HTML. We can download the full web page. We can see for specific keywords in the HTML like login, password, sign in. We can see for tags in the HTML code, for forms. We can see if the HTML is trying to run some JavaScript code, trying to render something else. And when we start analyzing the HTML, we find things like this one, code obfuscation on the HTML. Here we see the HTML of a website that it's fully obfuscated. It has lots of invisible characters. The visible characters are encoded. A lot of random styleless sections. So all these techniques are used to make more difficult to analyze the HTML in this case. When we deobfuscate this site, we can see here that the real strings like credit card or identity, verify, a common string or messages that the attackers are sending to the user. At the last of the chain of information we can get from a web page, we can download the media content, the CSS. Here with the CSS we can see if the site will be responsive. We can get the favicons, the image, we can follow the external link, we can make a screenshot for the rendered website. So with all this information, we here see a phishing site targeting Orange, the mobile phone company. We see that they are using the favicon from Orange. We have the logo from Orange. We have a form asking for user information. We have a button asking for user interaction. These are all resources that we can use to decide if this is a phishing or not. And we have challenge on the mobile world to detect this, because if we are on desktop, we have all the power from a desktop and all the information that we can see from a browser with a browser extension. On mobile, we usually have less CPU and RAM, we have battery constraints, and they are not so common to have browser extensions on mobile browsers. So external tools that are not built in the browser have difficulties to access or to see the full information on the site that the user is trying to access. A lot of time we have sandboxed process, and a security application is not able to see all the information. And we also, a lot of times, we have connectivity or privacy constraints. Not always it is possible to send to a backend for an offline or for a backend analysis of a website, because sometimes we have no connection or sometimes we have privacy constraints. So how can be an effective mobile phishing detection system? We need to have a mobile application that is defending the user for installing apps and as a malware detection engine. And at the same time, we need to defend the user for the URLs they are visiting. We need to detect on device what are the URLs or what are safe websites and what they are not. And we have to have the possibility to have a offline analysis. We say that whitelist and blacklist are dangerous on their own because they are prone to 0-day attacks, but we have to combine them and use them, because blacklist work when they are updated and whitelist work to avoid false positives, but we need an on-device, fast and real-time aggressive phishing detection. And we need also to combine this with a more heavy analysis on server. So at last, here are some useful links related to phishing and related to attacks in Argentina. And thanks for watching. I will be here to ask and to respond some of your questions. Thanks all.